Hello everyone, welcome to the Prometheus deep dive. We are super excited to show you how to use Prometheus and how to take Prometheus usage to the next level. Before we start, a quick intro. Hi, I'm Goutham. I'm a software engineer at Grafana Labs and I'm a Prometheus and Cortex maintainer. I've actually started contributing to Prometheus about 3.5 years, 4 years ago, and later I started working on Cortex to provide a hosted Prometheus service. Between Prometheus and Cortex, I also was one of the initial authors of Loki, a logging project, an open source logging solution inspired by Prometheus.
Amazing. Okay, my name is Bartłomiej Płotka, and I'm an engineer working in the monitoring team at Red Hat. I love open source and solving problems. I am part of the Prometheus team, and I'm also a co-author of Thanos. On top of that, you might know me from the newly created CNCF Special Interest Group Observability, where we focus on the cloud native observability topics and projects like Cortex, Thanos, Prometheus, OpenTelemetry, and so on. So if you find this interesting, please visit us on this Git repository.
So let's start with a typical team. In this case, the team in which Kate and Tom are a part of. So they run an API service. They've successfully built and launched that API service, and it works really well. But a couple of days later, they notice that their users are looking at 500 issues or 500 errors, and they're trying hard to debug what is throwing these 500 errors. Is it the load balancer? Is it their own application? Is the database locking up? Is the database being slow? What was the cause of it? To debug this, they were adding more logs and deploying into production to try to figure out where the error was being introduced. Now, this is not ideal, and this was frustrating Kate and Tom. So Kate decided to look into how to fix this. And the easiest way to fix this is to add monitoring. In this case, Kate actually chose Prometheus and Grafana, the golden stack. And she added an exporter in front of the load balancer and the database, exposing all the metrics of the load balancer and database. And she also instrumented the application itself to expose Prometheus metrics. Prometheus now collects all this data, and Kate can now alert on 500 errors or other issues. She also added dashboarding on top of it. So whenever there's an alert or an issue, they can directly look at all this dashboard with all the information to directly figure out, okay, the database is having issues, which is why we are throwing 500 errors. So their outages didn't stop, but whenever there was an outage, they could very quickly figure out what was happening, what was going wrong, and what to debug. And they were very quick at fixing all these issues. Looking at their success, the other teams also started using Prometheus. As is the Prometheus best practice, each team was maintaining their own Prometheus, they were maintaining their own Grafana, and all of this was working really well. Now, all the teams in the organization were using Prometheus, and as the usage of the organization and the application grew, they started deploying to several data centers. Again, as is the Prometheus best practice, you deploy a Prometheus per data center. The next slide, yep. This is because Prometheus needs to be close to the application it's monitoring. So in this case, they were deploying to US Central 1 and US 2. And whenever there's an alert, the alert actually contains which Prometheus generated this. So if they're looking at an alert from US Central 1, they directly go to the Grafana of US Central 1, look at the system and see what was going wrong, and it was all working really well. Until
at some point, Kate and Tom wanted to figure it out how to aggregate the data on the global level from the multiple Prometheus servers. Right? So let's imagine that Tom wanted to answer maybe a simple question, right? What is the error rate of the HTTP requests made by or received by his service, right? And he wants to aggregate and know the rate across all the and some of those rates across all the clusters. And as you remember, in each of those there are Prometheus servers, so we have essentially, we had to aggregate from more than one Prometheus servers. How to do that just using Prometheus alone? Now, well, you cannot use Query API, which is kind of the first thing you would try to use, and this is because PromQL evaluation is made on the leaf node. So once you have the data from two sources, there is already PromQL evaluation made. So you would need to have another layer of query evaluation to be made to adjust, to add additional aggregate, like for example, sum, to summarize those results together to tell you the overall error rate, for example. Now, this is not trivial work because there are lots of catchy things and caveats like additional load on doing PromQL and resolutions and steps. So all of this is not easy to solve with using Query API. However, the Prometheus allows other APIs to solve this problem. And first of those APIs is a federation API, let's call it. In this kind of scenario, we are deploying another Prometheus server on top of those cluster, maybe in another cluster, maybe in one of those clusters. And you configure this Prometheus to scrape a federate endpoint that those leaf Prometheuses expose. And it scrapes like a normal scrape, very similar. So even you create a scrape configuration for that. And this kind of works great until you have huge or bigger amount of data in those leaf Prometheuses. Because as you can imagine, if you are scraping and replicating all of the data into the global Prometheus into the global Prometheus server, it grows in the same with the same kind of pace as the leaf Prometheuses, because you replicate all of this data and suddenly you do that for the single instance that is running on the single machine. This causes lots of problems. So the thing that we suggest as Prometheus maintainers and the community, you should only use federation for only for subset of your data. And the easiest way to do that is to essentially create recording rules for the things that you want to have on the global level. And also you can, thanks of that, reduce the cardinality of the recorded data because you can sum aggregate across those. And you configure federation to only federate, to only scrape the rules by the parameter of matcher. And well, because of that, you need to also adjust the query that Tom has to make to query essentially recording rule, not the data itself. Anyway, the valid and the precise answer is available for Tom, so Tom is most likely happy. However, there are other options as well. The third option is really similar to the Query API, where you just provide a query that has to be evaluated for your answer. Instead of that, you are going deeper and trying to access the actual samples stored in the database of Prometheus. And this is the API that allows that is called remote read. So in that API, you are using a slight different payload. It's not a JSON, it's protobuf. Is actually should be familiar to you if you are using gRPC protocols. And inside that API, you are specifying the matchers. So we are matching a certain data that you want to fetch. And then you need to have some kind of automation that will do some nice work from it. And one of the example of the projects that allows you to do that is Thanos. And essentially Thanos allows you to add a sidecar to each Prometheus that is using this read protocol, and then expose it into the gRPC that Thanos is using. And then you essentially allow yourself to create, to deploy a global query component, which does the PromQL evaluation on the global level, having the data from each Prometheus separately. So, and this is how you can essentially transparently have the global view without recording rules and without replicating all of your data multiple times. However, there are other challenges when we are thinking about, bigger adoption and more users. So at some point, Kate was kind of annoyed that she has very short metric retention, only, a couple of weeks. So she thought about, hey, what about maybe longer one, maybe years of data, so I can analyze my my data. Maybe also some teams have the policy to store the metrics for whatever was like life period of your service. So it is kind of crucial requirement for some companies. So it would be beautiful if you would be able to just query those directly into Prometheus and just have those 2 years query working smoothly. And I can tell you that this is totally doable with just Prometheus. there is a misconception that Prometheus is not suitable for long-term storage and you have to deploy some external systems and have some integration. That's not always the case, because especially from Prometheus 2 and the recent versions of Prometheus, we made sure that the older data that you store actually adds marginal resources when they are not used. So whenever you are just querying short period of times and mostly from our experience, people are queries, the very fresh data. Those older data, even for years time, are not really increasing your resources. So it doesn't, the resources and consumption of those resources for Prometheus server doesn't scale with the retention that you give it. And to make it easier for you, we would really recommend setting, some large disk and try to precisely plan the capacity of the disk space, because you want to avoid kind of, resizes and things like that after those years time. So it's totally doable, and we have lots of users who are having 2 years data on their Prometheus server. However, yes, there are some trade-offs. After all, Prometheus was mainly focused on the monitoring for recent data and alerting. So there are some caveats. One of it is that it's super hard to efficiently or effectively plan capacity of your disks, because there are lots of unpredictable spikes. It's hard to sometimes control cardinality of the data you're ingesting. So it's not the easy task after all. The second problem might be backup. If you have those disks, hardware can fail, and you have to have some backup plan and operational kind of structure of it, some scripts, automation, and it's not always the easiest way, especially on bare metal. And last but not the least, well, there is no native downsampling on Prometheus side, which means that the large range queries, like for example for 2 years, will fetch all of those samples into the PromQL engine, and PromQL has to run through all those samples to calculate your response. And while this is doable, it will take some time, and there is definitely some room for some downsampling that will reduce the resolution that you don't need for querying such a long time range.
Cool. So now in the organization, every team is using Prometheus, and now more and more users want to use Prometheus, and there are more use cases coming up. For example, let's say the marketing team comes to Kate and asks if they could use the data in their data lake or another database. Or maybe someone wants to use the Prometheus data and store it in a replicated or distributed database that is much better at storing long-term storage. How do you send all of this data to a different database? How do you do this replication? So Prometheus has a protocol called remote write. It's an extremely simple protocol. So in your Prometheus configuration, you just add a stanza called remote write. You name the remote endpoint. If you have any authentication on it, you specify the authentication, and then Prometheus will start sending every single sample it scraped to this remote endpoint. Now, typically, your Prometheus will scrape millions of samples a second, and sometimes you only want to send a subset of the data to the remote endpoint. And doing that is also extremely easy. You can use the right relabel configs to kind of specify what data you want to send over and what data you want to keep, or what data you want to drop. And it's a very powerful config. You can also manipulate the data before sending it over. So with this, you can send as much or as little as you want. If marketing just wants to look at the UI level visits, you can only send the metrics for the UI level visits to a remote store. And now this is extremely popular, and we already have almost every single popular time series database out there integrating with the Prometheus remote write and read natively. So we have a non-exhaustive list of projects, like about 25 of them, which kind of support Prometheus read and Prometheus write. And you will most likely see all your favorite TSDBs in there. But in case you want to send Prometheus remote write data to a different database that's not in the list, that doesn't have a existing integration, it's extremely easy to build an integration. We use the same protobufs. If you're familiar with gRPC, you will be familiar with this. So in this case, we are basically sending a protobuf message called write request, which is a list of time series. Now, what is a time series? A time series is basically the labels for the time series and the samples in that time series. So with this extremely simple protobuf, you just create the protobuf and send it across. Like Prometheus creates this protobuf and sends it across. And if you can actually accept this protobuf, you can store all the data that Prometheus sends to you. Now, one of the typical use cases for this is actually long-term storage. This is also another solution for the global view problem that Bartek was talking before. If you want to combine the data between US Central 1 and US 2 Prometheus, you just basically remote write data from both the Prometheus to a central cluster. And because all the data is in a central place, you can query the single central cluster and you get all your data that you want. One of the examples of the projects that you can use for this is Cortex, which I help maintain. It's also a CNCF project. You can also use Thanos or M3 or several different time series databases out there. So this is about remote write. I just also want to talk to you about metadata. This is extremely useful as you scale your teams. So one of the things that we notice is new people come to the teams, they look at dashboards, and sometimes it's hard to understand what a particular PromQL query is doing. PromQL itself is simple, but if you don't understand what the metric means, it's extremely hard to figure out what the query means. And in most cases, you will be able to figure out just by looking at the metrics. For example, node CPU seconds total. So this, you can kind of guess, okay, this is the CPU usage per node. And the reason of behind this, behind the obviousness, is because we have an exhaustive and really nice guide on how you should label your metrics and the labels. Always follow the naming best practices. But sometimes when you deploy an exporter, it might not follow the best practices, or even after following the best practices, sometimes the name, the metric or the query is not clear. For example, cube node status capacity. You kind of don't understand right away what it is. To help with that, we actually expose the help and type information for every single metric as part of the exposition format. So if you hit the /metrics page, you will already see, for example, in this case, we can see that Go GC duration second is a summary of the past duration of garbage collection cycles. Go routines is a number of Go routines that currently exist. So we already have all of this information that is being exposed by all these applications. So in previous versions, Prometheus was not able to store all of this data, but in the recent version, starting 2.17, I think, we actually store and expose all this metadata inside Prometheus itself. So we now have the metadata API where you can query for the metadata of a particular metric. Next slide. Here you can see it's /API/v1/metadata. You can specify the limit, the number of metrics you'd like to return. And also, if you want to look at a metadata of a particular metric, you just pass in the metric name and it will give you the metadata for that. You can already use this, like you don't need to hit this API. It is part of the UI in Grafana 7.0. So if you're using Grafana 7.0 or the Explore tab or even the dashboards, whenever you type in the metric name, it kind of helps you figure out what the metric is. In this case, you can see this cube node status capacity CPU cores is a gauge, and it's a total CPU cores of the node. So this is super useful, especially for newcomers to understand what is happening. Now, just as an aside, we are having a new React UI as part of Prometheus. So if you're running Prometheus, we have a tiny, new, shiny, try experimental UI button. Just click on it and you will be taken to the new React UI. We're actively developing this UI, and the same feature, the metadata expansion, will be part of this UI as well. And we would like all of you to test this UI. If you have bugs, please file issues. And if you're a front-end developer, please contribute to all the issues around the new UI. This is going to be the future UI of Prometheus. And don't worry about breaking things. If something breaks, you can basically click on the classic UI and go back to the old UI. All right. So going to the future of metadata, we are just not done with metadata yet. So we currently store metadata in memory. but now in the future we want to persist this metadata. So over time you will be able to see how the help text and types of each metric evolved. We also want to be able to write these metadata, write all this metadata to remote systems like Cortex or Thanos, so that even when you're using the remote system, you have the same APIs and same data. We already have a PR for it, and there was a lot of discussion around how this PR should be structured, a lot of contention. But in a recent dev summit that happened a few weeks ago, we've reached consensus, and hopefully, in the next release or two, you will have remote writing of metadata.
Thanks, Goutham. So in the same Dev Summit, we actually discussed more items, and one of the further discussion points were backfilling, and this is like very wanted feature of Prometheus. So imagine that our team and Katie really wants to import the metrics into the Prometheus from other system. Maybe she's using some other Prometheus or some other system. She wants to migrate the data into her existing instance. So how do I do it with Prometheus, right? So it was always available, this kind of way of migrating and allowing to query your data from the other systems using Prometheus. It's called remote read. So you can configure your Prometheus to read from the external system, for example, InfluxDB. So every time you query something, it will go to that system. But this is not really backfilling, right? Because backfilling means that you want to import of data into your Prometheus storage directly to persist that and use it for future. So how do I do this? Maybe it would be super amazing if Katie could just put and write some CSV file, which is easy to play with and just generate, and import it into the Prometheus storage. Now, well, this is or will be possible very, very soon. So we started like the actual work on adding support for importing from two file formats, CSV and OpenMetrics. And it will look like this. You will essentially have a tool called tsdb import, and you just pass the file that will stream the data into the rows, let's say, into this tool, which will generate the blocks, which is kind of parsed and understandable by Prometheus tsdb database. So once you generate such blocks, like such files, you can just copy them onto the Prometheus working directory, and Prometheus will immediately reload that and allow you to access everything. Okay, now let's try to show you how it can look like once everything is merged and available. So let's go to my terminal and let's play with it a little bit. So let's imagine we have some data to import, and well, I don't have any CSV file anywhere handy, so maybe let's do something quick. So I will go to demo robust perception server. Let's pick some nice interesting metric to import. I really like this 1 hour range of Go routines for all 4 services, so let's just grab that. So I just quickly wrote a very handy bash script, which essentially queries that server and generate the CSV file from it. So let's quickly run that. In the CSV file, I can specify different fields by headers, and essentially let's show it. You can see that I kind of define the type of the field by the field name and by the in the header. So all those label name, label values are defining essentially what part of the CSV file field is for label values or names, or what are the actual where you put timestamp and where you put values and things like that. So now we generated like 1,000 rows of data. So let's install our tsdb tool. You can install this via such command, via just go get, and essentially I'm pulling a certain commit that is essentially part of my pull request, so ongoing work, but should be available soon. Once this is installed, I can hopefully run tsdb tool to generate my my block. Once this is done, let's check our help. of such tool, you can see the new available commands: imports open metrics and imports CSV. Let's actually do that, right? So we will cut our file into the ThysDB import tool and output that in some directory. This is actually kind of fast because we don't have much data. It's only 4 series, and it generated a block of 1 hour block, essentially, that has following ID. You can see that block is written and have all the necessary files for our ThysDB to understand that. So let's just run Prometheus, right? So I would just create empty configuration, doesn't matter. We just want to have something that will read the storage and just run the Prometheus, yeah. Now let's see if our data is available. So as you can imagine, app is not there because we actually uploaded Go routines, and it is available. So when we execute for our needed time range, we will see the data available for us. And you can see that this data is exactly the same as on our robust perception server, but actually robust perception server has more of it versus our server has only imported only a bit of it. So that's a demo, and this is the future. So it's super exciting to explore and extend that idea further.
That was great. To summarize, we've initially talked about how to do global view, how to aggregate data between several different Prometheuses, the different ways you can use to do that. And then we've talked about remote write and long-term storage, how you can use just Prometheus, what the caveats are, how you can use remote write to a different server, and how you can do global view through remote write. We've talked about metadata, one of the new features that I'm super excited about. And finally, we've also talked about backfilling and the future features that are coming into backfilling. So this is something I'm super excited about, again, because it'll help people migrate from older systems to Prometheus with all their data. All right, that's it. If you have any questions, feel free to ask them now, or you can reach us via Prometheus community or on GitHub.
Thank you.